The second equation in a state space representation format is y of t equals to cx plus du. It describes the relationship between the state vector, the input, and the output. So my state space representation is going to have two pieces. One is the equation that describes the relationship between x, u, and x dot, and this equation describes the relationship between x, u, and y. Let's see some examples. I want to write down the block diagram and state space format of this differential equation and then this differential equation. Do you remember how we used to write block diagrams? We used to draw block diagrams of differential equations. Well, we can do the same thing here, but actually if I do state space, it's going to be much easier if I do state space first. So for state space, we label the variable of the differential equation as our first state. So this would be x1. My differential equation is a first order differential equation. So that is enough. I would just call this x1 and that's enough. I don't need an x2. This would be x1 dot. Okay, so x1 dot. I just need to bring this term to the right hand side. So I'm going to have x1 dot is equals to negative x1 plus u. And that's it. That's the equation that I want to use in state space format. And I need an equation for output. I need an equation that has y on one side and x's and u's on the other side. And look, I already have that. I have y equals to x1. So my ABCD matrices that describe x1 equals to ax plus bu, y equals to cx plus du would be negative 1, 1, 1, and then 0. How do I plot the block diagram of this system? Well, I start by showing a point on the map as y or x1 here. Then I generate x1 dot. Then I look at my equation. My equation says x1 dot is negative x1 plus u. Okay, so I can create negative x1 and then a u. And then I have y equals to 1 times x1. So it's very simple here in this example. How about for the second example? So here, this equation. Do you remember how we would write we would draw the block diagram if we had u dot or u double dot on the right hand side? We would first write the transfer function, then break it into the numerator and the denominator, introduce a new variable called v, and then we would write it down, write this differential equation as two differential equations, and then we would plot the block diagram, right? So we do that here. Take the Laplace transform, write the transfer function, break it into two pieces, and write two differential equations, which we don't have u dot in them anymore, nor do we have y dot. The only variable with dots and double dots is v. Then what we do is that now we want to write state space representation for these two equations. So what I can do is to call v my first label x1, v dot now would be x2, and therefore I can write this first equation here as x2 dot equals to 0.5 x1 negative 0.5 x2 plus u. This is plus u. How do I write this first row? Well, the first row is saying x1 dot is equal to 0 times x1 plus 1 times x2 plus 0 times u. So basically, the first row is just saying x1 dot is equal to x2. Do I have that anywhere? Yeah, it's here. x1 dot is equal to x2. How did I write this second equation? Well, what does this say? It says y is equal to negative 0.5 x1 plus 1 x2. Where do I write that from? Well, from this equation. From this second equation with a y, if I substitute x1 for v and x2 for v dot, it becomes negative 0.5 x1 plus x2, which is what I have here. And then I can plot the block diagram the way I had before. Now, how about MATLAB? How do we define state space representation using MATLAB? In MATLAB, the command for state space representations is SS. So if you know what A and B and C and D matrices of your state space representation are, you just write SS of A, B, C, D, and then it's going to define for you the system. An alternative is that if you know the transfer function of the system, you can just call SS command on your transfer function, and it's going to write down your system or the state space representation of the system from your transfer function. Okay, let's see this additional example. I have this differential equation. I want to write the system in state space representation and plot the block diagram. All right, the first step, I have a u dot on the right hand side. So what I need to do is to write down the transfer function. Then break it into two pieces. Introduce a new variable called v. Call this system y divided by v, and this system v divided by u. Then I write down the differential equation based on u and v. So I'm going to have these two equations. Notice that I don't have any u dots or y dots, I only have v dots. Now I want to label my variables. So this is my differential equation, this is the second differential equation, and I want to call v x1, and then v dot would be x2. Why am I only labeling v and v dot and not v double dot? Because v double dot is the variable with the highest order. I want to keep that to be able to write to keep it on the left hand side. So v would be x1, v dot would be x2, and v double dot would be x2 dot. So this equation then can be written as x2 dot equals to negative 2, bring it to the other side, negative 2 x2 plus 4 x1. And then I have a u here. So I'm going to have this equation. And I can place it in the matrix format. I'm going to have x dot 2 equals to 4x1 negative 2x2 plus 1u. How would I write the first row of this equation as well as the output? Well, I want an equation to describe the relationship between x1 dot, x1, x2, and u. Can you show me an equation here on this slide that is describing the relationship between x1 dot and then x1, x2, and u? It's here. x1 dot is x2. So I'm going to have 0 times x1 plus 1 times x2 plus 0 times u. Can you show me an equation that describes the relationship between y and x1, x2, and u? It's here. Y is equal to negative v, so x1, negative x1, plus 3 x2. So negative 1 plus 3, and then this is 0. Okay? And then for block diagram, we do what we did before. We start with this equation. We are going to bring v and v dot to the other side. We are going to have v double dot equals to u minus 2v dot plus 4v. We show a point on the map on the page with v. If there is a block here with 1 over s, the signal that goes inside that block would be v dot, and then the signal that is here would be v double dot. So I have v double dot is u plus, or here I have negative 2v dot, so I can show it with plus negative 2, or I can just put a 2 here and then negative sign. And then plus 4v. Then I go to the second equation, which is y equals to 3v dot negative v. I already have v and v dot on the, I know where they are on the page. So I take negative 1 times v and then 3 times v dot. I add them up. That would be y. That's what the equation says. And this will be the block diagram. If I want to define the state space representation, it's enough to first define the transfer function, and then for system 1, and then I just call ss command on it. Alternatively, I can do tf to ss. If I have the transfer function, I can convert it to the state space representation.